Hi there everyone, welcome back to the channel. I'm the GCSE science teacher, and in today's video we're going to be learning about visible light, which is part of the electromagnetic spectrum and is also part of the GCSE physics content here on my channel for those of you who are studying this. I hope you guys do find this helpful. If you do, let me know in the comment section. Feel free to join this community by subscribing, click the bell so you get notified. I do upload new videos every single Sunday here on YouTube, so please do join us for that. And thank you so much for all your support already. I do appreciate every single one of you guys. So yeah, let's get started. Let's talk about the colours of the rainbow first of all. So like I said, we can actually see a part of the electromagnetic spectrum with our own eyes, and this is called the visible light spectrum. But electromagnetic spectrum, or EM waves, are essentially a whole host of different wavelengths of ultraviolet, radio waves, X-rays. We've got infrared. We've got all different types of waves, but they're all transverse waves. And I have done a whole video on waves on my channel, so I'll link it for you if you need to go back and watch that and revise it. But today, specifically, we're going to be talking about visible light or white light and how this can be split up into those different colours that we perceive and how we perceive these colours as well. So I hope you guys do find this useful. So what I mean by white light or visible light is a mixture really of different colours or wavelengths. And we can see that we have red, orange, yellow, green, blue, indigo and violet, otherwise known in the mnemonic Richard of York gave battle in vain. That's just a way to remember that red is at the top in terms of the fact that it has very long wavelengths, it has a very low frequency, or you can see in this case low hertz, which is Hz, that's the unit of frequency, and wavelengths unit is lambda, which you can see there. And as we go across the spectrum from red all the way to violet, we can see the opposite happens here. We've got very short wavelengths and a very high frequency for violet light. And it's because of these different wavelengths and different frequencies that our eyes actually perceive this as the different colours of the spectrum. And we can actually split up these lights if we use a prism. So you've probably seen a rainbow before when it's raining and then it's sunny. This is because each of those rain droplets acts as a prism, and it actually causes the light to refract or bend and change direction as it goes through a different medium. Originally it was in air and then it goes through the water, and this is a different medium and actually changes the direction of that light traveling because of the density that has changed. And we can do this again with a prism as well. And yeah, this is how we're able to see those different colours of light. So we're going to look at the transmission of light now. So you may have heard of the situation where people will say if it's really hot outside, not to wear really dark clothing like black because it will absorb all the heat and it will make you warmer. In fact, lighter clothing, white clothing reflects a lot of light and it cools you down. And this is exactly the case. So if you look at animals in, say, the Arctic, like polar bears, they actually have black skin. And this is to absorb any UV radiation, to absorb that heat and keep them warm, whereas the white colour is essentially the fur that helps them camouflage from prey. So they're very smart in that sense because they're actually using this idea all the time. And we actually see this in the case of opaque objects. So anything that is opaque, it's solid in color, you can't see through it, it will be able to absorb a lot of that light. Whereas translucent objects that you can kind of see through, they will absorb a medium amount, but transparent objects, they will absorb the least amount because light goes straight through it. It's highly penetrative. And we're going to talk about why absorption of light is really important, specifically in terms of color and how we perceive it. So if we look at the different colours of light that white light is made up of, the reason we see objects the way they are is because of how that light is absorbed, but the colour that's reflected is the one that we see. So if we look at, say, for example, a red apple, if white light is shone on that apple, all of the colours are absorbed except for the red wavelength. This is actually reflected back off the object, and this is how we perceive that colour itself. So if you've ever been in a very hot, sunny environment and you've worn sunglasses, you'll often see that the colour you perceive through the sunglasses is changed slightly than the real colour that you see without them. And this is what we call a filter. So it's a way for light to transfer through a slightly tinted, slightly coloured object, and this changes what is actually reflected and what we perceive the colour to be on everyday objects. So let's say, for example, we have a green filter. The white light will pass through that green filter, but the only colour that is transmitted is the one that we see. So in the case of the green filter, green light is transmitted. And this, again, can also what we see around us. So let's say that green filter was in our sunglasses. Everything would have a greenish hue, but some objects wouldn't appear green. And I'm going to show you why that is the case now. So let's go back to the example of the red apple. As you can see in this case, we've got three different filters, and you can actually see that the apple appears different in each of those filters. So if we add the apple in the green filter, all of the wavelengths of white light are absorbed by the green filter. The green light is the only one that's transmitted through, and it goes to the apple and is absorbed fully because the apple itself, except for the leaf, is red. So the green color of light, that wavelength is absorbed, so it therefore appears black to us. However, the leaf itself, because it's green, it will actually reflect that green light back to us, so we would see that leaf. If we used a red filter, the inverse would happen. So we would actually have the red apple showing true to be red because all the wavelengths have been absorbed by the red filter. The red wavelength will be transmitted through that filter and essentially reflected from that apple. However, it will be absorbed by the leaf and the stem and therefore appear. In the case of the blue filter, the wavelengths of light are absorbed through the filter. The blue light can be transmitted through onto the apple, but because none of the apple itself is blue, the wavelength of light is absorbed, and therefore everything about the apple appears black. Remember, the black color is as a result of absorbing all the wavelengths of light. And that's it from me today. I've been the GCSE science teacher and you've been curious. If you did enjoy this video, feel free to give it a thumbs up, share it with someone else, and do subscribe if you haven't already. Thank you so much for all your support. Perhaps you'd like to watch another video I made about the human eye and how that works, or even about red-green color blindness that links nicely to this video. I'll leave those for you in the description box or at the end of this video as well. Have a great day, and I will catch you in the next one. Take care.